it's another case if the limits involve radicals. So to manipulate or to evaluate or find the limits of involving radicals, we are going to manipulate the function so that the powers of x are transformed to powers of 1 over x. And we can achieve that by dividing the numerator and denominator by x and using the fact that the square root of x squared is equal to x. Or it could be other indices. Let's square root of x to the power of 4 is x squared, or square root of x to the power of 6, or x cubed. So for example, we are finding the limit of the square root of x squared plus 2 over 3x minus 6. So this is still a fraction, and we can see here that the degree actually of the polynomial in the numerator and denominator are equal. Why? The degree in the denominator here is 1. This is x squared right here, but we are extracting the square root, meaning the square root of x squared is equal to x, right? And so we predict that because the degree of the polynomial in the numerator and denominator are equal, we predict that the answer here, or the limit here, is just their coefficients, which is 1 for the numerator and 3 for the denominator. So we expect an answer of 1/3. But let's try to see if our answer is correct. So because the degree is equal and we have to transform into the 1 over x form, so what we're going to do is to divide both numerator and denominator by x. So dividing the denominator by x, that would be 3 minus 6 over x as x approaches infinity. But remember that x is equal to the square root of x squared. So we have to divide the numerator by the square root form because also this is in radical form. So we're going to write the numerator as the square root of x squared plus 2 over x squared. So recall also that the square root of a over b is equal to the square root of a over the square root of b, meaning square root of x squared plus 2 divided by the square root of x squared is just equal to the square root of x squared plus 2 all over x squared. And so dividing that by x squared, this is equal to the limit of the square root of 1 plus 2 over x squared over 3 minus 6 over x as x approaches infinity. And so when we evaluate the limit now, this will become 0, and this is also 0, and the square root of 1 is 1, and so our answer is 1/3 indeed. Okay, second one. The limit of 2 minus x squared over square root of 6x squared plus 7 as x approaches infinity, which has a higher exponent. So because this is x squared right here, again, when you extract the square root, this is just the square root of x squared, which is x. X in the denominator, x squared in the numerator, meaning we are going to divide both the numerator and denominator by x squared. But because this is in radical form, then what is x squared equal to in radical form? That it be the square root of x to the power of 4. And so dividing both numerator and denominator, we write limit dividing by x squared, that's 2 over x squared minus 1 divided by square root of 6x squared plus 7 over x to the power of 4. Again, we use the fact that the square root of a over the square root of b is equal to the square root of a over b. And so the square root of 6x squared plus 7 over the square root of x to the power of 4 is just equal to this one as x approaches infinity. And so evaluating the limit or simplifying this radicand in the denominator, we can write that as the limit of 2 over x squared minus 1 all over the square root of, that's 6 over x squared plus 7 over x to the power of 4 as x approaches infinity. So this would be 0 minus 1, and this is 0 plus 0. And so that would be 2 over 0. And so our answer is that the limit does not exist. So we were able to predict that indeed the limit does not exist because the degree of the numerator, x squared, is greater than the degree of the denominator, x. So that's for limits involving radicals involving radicals in fraction form. But how about if there is no, it's not fraction? So we're finding the limit of the square root of x to the power of 6 plus 5 minus x cubed as x approaches infinity. Now remember that we have to transform it into the 1 over x form to find the limit. So in this case right here, we have to perform rationalizing. We have to rationalize by multiplying the numerator and denominator by the conjugate. So this would now be the limit of the square root of x to the power of 6 plus 5 minus x cubed, multiply it to square root of x to the power of 6 plus 5 plus x cubed over the square root of x to the power of 6 plus 5 plus x cubed. So remember that if we have to multiply with a term in the numerator or denominator, we also have to multiply it in the numerator and denominator as well, because this is just equal to 1. And so when we multiply something, it has to be equal to 1 so that we do not change the given. So we're just changing its form. So when we multiply this one, we remember or we recall the product of conjugate binomials u plus v times u minus v, which is equal to u squared minus v squared. And so the first term here will just be raised to the power of 2, and the second term right here will be raised also to the power of 2. So this is now equal to the limit. Remember that we are not yet substituting, so we do not remove limit yet. We are not yet evaluating. So squaring that, that's x to the power of 6 plus 5, right? We just remove the radical. And raising this to the power of 2, x cubed raised to the power of 2 is equal to x to the power of 6. So minus x to the power of 6. And so we are able to cancel x to the power of 6. But that's divided by the square root of x to the power of 6 plus 5 plus x cubed as x approaches infinity. This is still not yet in the 1 over x form, so we have to divide both the numerator and denominator by the highest degree term, which is when we extract, this is x cubed right here, but when we extract the square root of x to the power of 6, it's still x cubed, meaning we divide both numerator and denominator by x cubed. So that's the limit of 5 over x cubed divided by, so this is x to the power of 6, but we know that x cubed is equal to the square root of x to the power of 6, right? So this is equal to x to the power of 6 plus 5 over x to the power of 6 plus 1, because this is x cubed over x cubed as x approaches infinity. So this is then equal to the limit of 5 over x cubed over the square root of 1 plus 5 over x cubed, or x to the power of 6 rather, plus 1 as x approaches infinity. And so upon substituting, this becomes 0, right? This is also 0, so square root of 1 is 1 plus 1. So this is equal to 0 over 2, which is just equal to 0. So if there is no fraction involved and there are radicals and x is approaching infinity, we have to perform the rationalizing by multiplying with a conjugate binomial.